We're going to look at a useful symbol now. It's a new symbol probably to you, although you may well have seen it on a spreadsheet formula bar. This is the symbol. Looks like an M on its side, but it's actually called sigma. It's a Greek letter, like most other math symbols. That's where they came from. And the symbol means add up all these values. It's often referred to as the summation formula, and that's how most spreadsheets use it, as an icon on the button that enables you to put the sum formula into a column or a cell. Let's have a look at how we actually use it. So here we've got a table of values. We've got 10 values here, and we've labelled them x1, x2, x3 and so on all the way up to x10. And that's often how you'll see data items listed, with the number of the data item in the sequence as the subscript to a letter. So our data sequence is a data sequence of x, and its values of x1 all the way up to x10. If we were to work out the mean of these items, we would add up the values and divide it by 10. So we would do x1 plus x2 plus x3 and so on all up to x10, add those up, divide it by 10. We use the sigma notation to avoid us having to write down all of these values. Instead of that long list of x1 all the way up to x10, we would use the sigma notation and write it down like this. This means the following. It means to sum up all of the values of x starting from x1 all the way up to x10, and then divide the result you get by 10. So at the bottom of the sigma we put the value that we're starting from, the I equals 1, so that's where we'd put the index there, and at the top of the sigma we put the value that we're going up to, so that was I equals 10. We don't need to write the I equals again because we've already done that. And then the sigma sign just means keep adding them up until you get from 1 all the way up to 10. Do not be confused into thinking that we mean add up 1 plus 2 plus 3 plus 4 plus 5. We don't. We mean add up x1, x2, x3. So in our example we mean add up 23 plus 27 plus 34 plus 26 and so on until we get all the way up to x10, which is 34. That's how it would work in this case with this set of data. Let's generalize the equation for a set of n data items, and we would then write it as follows. It would be sigma I equals 1 to n of xi divided by n. So sometimes we just abbreviate this to sigma x, where it is clear that we're talking about a particular set of data. This notation is probably new to you, so I suggest you review this video again to make sure that you've understood exactly what it is that we're trying to get across here. Let's now do an example to see that we have understood exactly what's going on. So a whole year group takes a maths test. The results have been summarised for us. So we've got a number of students equals 155, and we're given the information that for all of the data, sigma x is 7,233. The question we're asked is, what is the mean test score? Well, the solution is that the mean is the sum of all of the data divided by the number of items of data. So in this case it's clear that the mean score is equal to sigma x over n, which in this case is 7,233, because we're given that data above in the question, divided by 155, the information we're also given in the question. So that means our mean is 46.66. So again, as with other questions of this type, don't be fooled into thinking they're harder than they actually are. The mean is still the total of all of the data items divided by the number of data items. They're just being given to you here in a different format. When we're faced with large amounts of data, as previously, we'd want to organise this data into a frequency table. So consider this list of data here, which we can organise into the following frequency table. So we've got the scores, possibly in a test, and the frequency within which they occur. And we have a total of 60 items of data. Now we have the frequency table, we can see straight away that the mode of the data is 23 because it's the largest single item of data. It's got 12 data items. The median, because there's 60 data items, is the mean of the 30th and the 31st items. So we need to find out whereabouts they are in this table. We can do this by adding up the frequencies as we go down the table. So the first one is 6, then the next frequency is 0, so the cumulative is still 6. The next one, the cumulative, is 18, then it's 24, and then it's 33. That means that the 30th and the 31st values are in that frequency of 9. So the median numbers, 30th and 31st items, are both 25. So the mean of those is 25. So the median is 25. Now we need to see how we'd work out the mean. So let's write our table down again and remind ourselves of what we know already. We know there are 60 items of data, we know the mode is 23, and we know the median is 25. The score is our value, so we're going to call that xi. Our frequency we're going to call f. To work out the mean, we're going to use the frequency and the following equation. We're going to say that the mean is equal to the sum of the score times the frequency divided by the sum of all the frequencies. We can write this down more formally as follows, or as sigma of I 1 to n of xi times fi, all divided by sigma from I equals 1 to n of f of I. If you can't see exactly what this means, go back to the beginning of this video and look and see how we got to that particular equation. So what we're going to do is we're going to extend our table with a further column to help us. We're going to put in that x of I times f of I column. And so we're going to do that. 6 times 21 is equal to 126. 0 times 22 is 0, obviously. 12 times 23 is 276, and so on down the table. We're then also going to need now the totals of those two columns. The total of the frequency column, well, that should be 60 because we know there's 60 data items. And the total of that xi times fi column is 1509. So our mean is 1509 divided by 60, which is equal to 25.15. So sigma notation is a little bit like algebra. It's a way of avoiding writing down large amounts of text, something that mathematicians really don't like doing. So we use the notation to avoid writing down x1, f1, x plus x2, f2 plus x3, f3 and so on, which if you've got 4 or 5 items is not too difficult. If you've got 1,000 data items, you wouldn't want to write that all down every time. So we abbreviate it using the sigma notation. Make sure you've understood how we've used the x times frequency idea to work out the mean as well. That's a fairly simple and straightforward way of making sure that we're adding all the numbers up, but we're doing it by multiplying how many of each of those numbers we have rather than adding them several times over. Again, as with all maths of this kind, there's a lot of steps involved, so make sure you write down all the information as you go along. You're much less likely to make mistakes if you do it that way.